Hello everyone, I'm Meghamala, Working Assistant Professor from Institute of Aeronautical Engineering ECE Department. And today I'm going to discuss about the question bank discussion based on half subtractor, okay, from the switch level modeling. So this today's topic is about question bank discussion that is based upon the half subtractors in the switch level modeling. So we know that in the Verilog we have discussed so far the four types of different modeling styles, right? Behavioral modeling, gate level modeling, behavioral modeling, gate level modeling, data flow modeling, gate level modeling, data flow modeling, and switch level modeling, right? So as we have discussed few questions based on behavioral modeling, data flow modeling, and gate level modeling, right? And today we are going to discuss some questions that how to solve if you come across a question based on the switch level modeling. So coming to the switch level modeling is one of the basic modeling that we can see in the Verilog. So here usually the switch level modeling, it comprises of different kinds of switch. So we know that there are CMOS switch. CMOS switch is nothing but it's a combination of PMOS and as well as the NMOS switch, right? So here by using the switch level modeling, we can able to draw, or else we can able to write the Verilog code. We can able to construct the Verilog code. And also we have different types of switches. The switches are present in the switch primitives. So we know that in the Verilog library, we have different primitives, right? So in the Verilog libraries, we have different primitives. Some are based on the gate. So in gate level primitive, right? Some are based on the switches. So most of the switches that we can acquire from this Verilog library, the switch primitives can be obtained from the Verilog libraries, right? So here based on the switch level modeling, we have discussed so far different types of switches. Bidirectional switches, unidirectional switches. There are different types of switches: bidirectional switches, unidirectional switches, and also we have discussed about the resistive switches, right? Resistive switches and so on. So these are the different types of switches we have discussed. So the resistive switches are nothing but they represent the RTRAN if 0 and RTRAN if 1, right? So these are the different types of switches based on the propagation of the signal which takes place from the input to the output as well. And now we will see that how to construct a half subtractor using CMOS switches. So now we will construct a half subtractor using the CMOS switches. So we know the combinational circuits are nothing but, see, a subtractor circuit is a digital combinational circuit that is responsible for the subtraction of 2 or 3 bit numbers. Okay, there are two different types of subtractors. So we all well know about the adders, right? In the right from the starting, like in the module 1, in the module 2, based on the gate level modeling, we have discussed different adders based on the inputs that you are considering. The first and the foremost thing, or as an important point about the adders, is we have discussed about the half adder. And also we have discussed about the full adder. So full adder consists of the 3 inputs, whereas the half adder consists of only 2 inputs. So when it comes to the adders, at the output we get the carry and the sum, right? Carry and as well as the sum. So if it is a full adder that you are considering, remember that your inputs are of 3, A, B and C, and output goes like sum and carry out, right? If you're considering the half adder, then your inputs will be A and B, 2 inputs, and the output you will observe as sum and carry. So this scenario we can see in the adders, right? That means what? We are adding up 2 inputs, or else we are adding up 3 inputs. More than 2 inputs, that is considered to be as a full adder. So we are adding up 2 inputs, sometimes A plus B, or else sometimes we are adding up 3 inputs, A, B, C, so that we are getting the sum and as well as the carry. But in the subtractors are nothing but here we are just subtracting. So right, so in the adder we can say that organ, right? In the organ we come across this word as organ, but whereas in the subtraction we'll come across a word called subtrahend. Okay, subtrahend, right? So here you're saying it is saying that there are 2 different types of subtractors. One is half subtractor, likewise a full adder. half adder, and the second one is full subtractor, likewise a full adder. So what is half subtractor and what is full subtractor, we will see. So the half subtractor is nothing but it subtracts two numbers and generates a difference. Obviously, the subtractor, it generates a difference, A minus B. For example, A and B are the two inputs. What happens is at the output, it generates a difference, right? And also a borrow output. It generates a difference and as well as the borrow, difference and borrow. Okay, whereas in the adders, we see that it generates the carry and as well as the sum, right? But whereas in the subtractor, we see that they generate the difference, right? They generate the difference and as well as the borrow. Okay, so borrow and difference we are going to observe at the output side. That is a half subtractor where it considers the two inputs A and B, for example. And then coming to the full subtractor. So what is this full subtractor means? Full subtractor is it also performs the subtraction of two bits. One is minuend and the other one is the subtrahend, right? So one is a minuend and another one is subtrahend, and taking into account borrow of the previous adjacent lower minuend bit. So obviously, if you are considering the full adder, you will see that there are three inputs, right? A, B, C. If it is a full adder, you have three inputs, A, B and C. But whereas at the output, you will observe the sum and as well as the carry, right? So what happens here? See, if you are adding up, add A plus, for example, you have 0, 1, 1. Okay, so 0, 1, 1. What is the output for this 0, 1, 1? 0 plus 1 is 1, and then 1 plus 1, that means what? The carry which is obtained by adding the two bits. Okay, the first two bits, after adding the first two bits, whatever the carry that you are getting, that carry acts as an input, and then that carry plus the other number, okay, other digits we are going to add up. Okay, that's how we are going to get the sum and as well as the carry. Okay, so then 1 plus 1 is 0 and carry 1. So this is we observe in the full adder. So similar pattern, similar fashion we can see in the subtractor as well. In the full subtractor, we are saying that one of the two bits, right? We will be subtracting first two bits. So among the two bits, one bit is called as a minuend and the other bit is called as the subtrahend. Okay, after subtracting these two bits, if you get any borrow, and that borrow will be considered that from the borrow which is considered from the previous bit is again again subtracted from the existing one, so that you are getting a difference and as well as the borrow. Okay, so the same fashion whatever you are following with the full adder, then the same replica you will observe in the full subtractor as well. And now we will see the general structure of Verilog. So now what is the main agenda is, like, we need to construct a half subtractor using what? CMOS switches, right? So now we will see the general structure of the Verilog code. It consists of, see, this is a general way of how to write the code. So first thing is, we'll just model declaration. We will write up we'll write our code starting with the keyword model declaration. And second one is input and as well as the output declaration. So the second thing is we are going to declare our input and as well as the output. And then final one, the third one is sensitivity list. So what is the main thing? That means what the sensitivity list, it's all consists of the combination of both the inputs and outputs, and also in what level you are writing your code. For example, if you are writing your code in the behavioral modeling, remember that you have to write the key which is pertaining to that behavioral modeling always at the rate, right? So that is a sensitivity list. So this sensitivity list also consists of the semicolons and all, right? Without the semicolon, as it is a case sensitive like C language. In the previous classes, in the very first classes, we have discussed that Verilog is a case sensitive language, right? Verilog is a case sensitive language. It means that you have to be very keen enough that how the declaration. Okay, if you are forget to declare the semicolon, then what happens is you'll get some errors. So that's what it is. A sensitivity list is a third point where we have to declare. And the fourth one is procedural assignment continuous statements. And then fourth point goes with the statements. And some statements are considered with respect to the continuous assignment statement, and some are considered with respect to the procedural assignment statement. So regarding these statements also we have studied in the previous classes. So the each and every statement consists of the variable nets, right, onto the left of the assignment operator, and on to the right of the assignment operator we will be observing some expressions, right? So this is what the declaration of procedural assignments. And then finally terminating the end module, that is ending the module. So this is the structure of how to write a Verilog code. And now we will see coming to the half subtractor. As we are discussing about the subtractor, the half subtractor consists of two inputs A and B. A and B are the two inputs, and so we get the output as different and as well as the borrow, right? So you see in the as I said you this half subtractor is a replica of half adder, right? So in the half adder what you have seen, we will be having A and B as the input, and at the output you will observe as sum and carry, right? So this is the half adders. Like when it comes to the subtractor, you will observe at the output as a difference and as well as the borrow. And now coming to the truth table pertaining to this half subtractor. So in the truth table you have A, B, difference and sum. So this all we know, like A minus 0 minus 0, the difference is 0 and the borrow is 0. And if it is 0 minus 1, the difference is 1 and the borrow is 1. And 1 minus 0, the difference is 1 and borrow as 0. And if both the inputs are 1, then the difference and borrow as well, they both becomes the 0. Okay, so this is we all know. And now we will see the module instantiation, or else the few lines which are how to write the code. In the code we are instantiating the module name and the port list. So this is how we will instantiate, right? When you're writing a code, when you're constructing a Verilog code, so this is the scenario that you will follow. So module, name of the instance, the module instance name, and then the port list. You all know that port list consists of input and output and as well as the in-out ports, right? In-out ports. Sometimes, for example, if you are considering some different combinational circuits like multiplexers or encoders. In the multiplexers or encoders, if you are considering such type of combinational circuits, remember that in the port list you have to mention the input port, output ports, and as well as the selection lines as well. When it comes to the multiplexer, if you are considering your encoders or decoders, right? Encoders or decoders, in the port list you must mention the input ports, output ports, and as well as the control lines, right? Control lines. Based on the control lines, you can able to get the enable pins. You can able to get the output as well, right? So this is how the port list contains, and then the declaration statements, and finally end module. And now we will see the half subtractor circuits. Suppose if we have two numbers, say A and B, right? In the previous diagram, we have seen that A and B are the two inputs. This is half subtractor. So that what are the things that we are going to observe is the difference and as well as the borrow, right? So these two are going to considered as the outputs, and then minuend and subtrahend respectively. So for example, if you're considering the half subtractor such that you are having two inputs A and B, one is a minuend and the other one is the subtrahend, right? Other one is the subtrahend. Then these will be the inputs to the half subtractor circuit, and the output generated will be difference and borrow. Okay, so these two, minuend and subtrahend, are they act as the inputs to the half subtractor, so that you get the output as the borrow and as well as the difference. And now, since we have two input variables, the half subtractor, it considers only two inputs. If for example, full subtractor, it considers the three inputs. Full subtractor considers the three inputs, full subtractor. Right? So here you have the two inputs as a half subtractor. Then the maximum number of possible inputs could be calculated based on 2 power n. Right? 2 power n. Based on this calculation, based on the statistics, we can consider the number of inputs. Right? And where n is the number of inputs. Then we will see. So here, if you observe, we have 2 power 2. Right? So here in the half subtractor, we have A and A is a minuend and B is a subtrahend, right? So this is nothing but the difference, and the one more thing is borrow, right? So here, as we know that based on the 2 power n, right? Based on the 2 power n, we are considering the input lines, so that the combinations, how much we get is 4 combinations we'll observe. So here for A and B, as they are the minuend and subtrahend, so the combinations that we can observe is 0, 0, 0, 1, 1, 0 and 1, 1. So 4 combinations that we can observe. For example, if you are considering the full subtractor, so from 0 to 7, these are the combinations that you can observe if you are considering your model to be a full subtractor. And see, this is the logic diagram for half subtractor. So we have two inputs A and B, so that we are getting a difference and as well as a borrow. So as we are constructing our half subtractor by using the switches, so that we are considering some gates, right? So A and B as the input. So this is a XOR gate and NOT gate and AND gate. So how are we going to achieve our difference and subtract borrow is, see, A XOR B, right? So this is a XOR B. So A XOR B, two inputs are given, so that we are getting the difference with respect to A and B. And now borrow, how we are going to get the observe the borrow is the A bar. So so this is the A, and the A is passing out of the NOT gate, so A bar, and B directly considered as from the B itself, so it's the AND gate. And now see, AND gate means not A dot B. Okay, so this is a XOR, right? XOR means this XOR A slash B. So right, so we will see now the very low code for half subtractor. How can we write is, we see that there are three logic gates being used. So what are the three logic gates that we have considered in the previous slide is, one is a XOR gate, the next one is the AND gate and the NOT gate as well. So here what we will do is, for all these structures are we know the structures, and from the structures we can easily generate our Verilog code, right? We can easily generate our Verilog code. So here each module will define the functionality of one of the three logic gates using the assign statement. So how we have to write our code? In our code we have to mention the assign statement. Why we are going for this assign statement? Because our structure is based on the gates, right? By using our structure is purely depends on the gates. So as we are designing our structure with respect to the gates, so such that we have to assign a keyword called the assign statement. Remember that in the data flow modeling, and the gate level modeling, the very important keyword that you have to assign in the Verilog code is assign. Assign is a keyword. If you want to write your code in terms of behavioral modeling, right? In terms of behavioral modeling, then remember that always at the rate, okay? Always block at the rate keyword is a main important keyword that you have to mention when you are generating the code, right? Then the first module is for the XOR gate. So now what we have to do is, as we are constructing a Verilog code, we have to segregate our code. How can we segregate our code is, as we in this structure we have three different gates, right? One is XOR gate, the second one is NOT gate, and as well as the AND gate. So in our code, as we are writing a code for the half subtractor, first thing is we have to segregate our code. So now what we are doing is, we are segregating our code as per the gates that are mentioned over here. That means what? For the first part, I have to write my code in terms of XOR gate, and the second part I'm going to write my code in terms of NOT gate, and the third part I'm going to write initializing the inputs, outputs, and also the mechanism as per the AND gate. That is the third part. So after writing all the three parts, what am I doing is, the last part is I'm going to club all this so that I can write a code for the half subtractor. So this is what we will see. We see now. Okay. So see this an important point to be noted here. See, this is an important point. The point says that, see, you know that this is an assignment operator, right? So this is an assignment operator, and onto the assignment operator, what we see is the LHS entity of the assigned statement must be a wire or vector net. So obviously onto the left, this is the left hand side, and this is the right hand side. So right hand side we are going to write the expression. Our expression is going to fall under the right hand side of the assignment operator, whereas onto the left hand side of the assignment operator we see only the wires or the vector nets. Vector nets or the data types or vector nets. Okay, so some vector nets are in terms of wires, and some vector nets are in terms of registers, like that. Okay, and now this is a very important point to be noted. And now remember that the register cannot be written, because register is a data type that we can assign, but we cannot write the register R1, R2 based on what move register or else delay register, like that we cannot instantiate. And now we will see, this is the one part, first part, this is a second part, and similarly one more part is there, this is the third part. Okay, so what are we doing is, based on the gates that we are considering, we are writing each and every code for this gate. So as it XOR gate is the first gate, XOR, we know that A, B, C, right? Inputs are A and B, and C is the output. And now assign is a keyword where we are using for this structural level modeling. So assign C1 is A and B, right? So A XOR B. So this is a XOR, A XOR B, and then in module. Similarly, we are going to write our code for this NOT gate and as well as the AND gate. So for NOT gate, so we have in the A3 and B3 input, output, and assign, right? Assign and then end module. So finally, for AND gate. So for AND gate, how are we writing is module AND gate, A to B to C2. My inputs are A to B2 and output is C2. So how am I going to write my output is assign C2, which is A and B, A2 and B2. So these are the, so this is how we will represent the AND gate, right? And then finally end module. And module instantiation consists of module name, right? This is a module name. So that is how you write the module name, and then instance name. Okay, instance name, that is what now we are writing our code in terms of subtractor, right? So this is a half subtractor, and then the port list, right? So the port list, inputs, outputs, and in outputs, inputs, outputs, and in outputs. And then the module instance is useful if you want to call the same module several times in the same program. That means what, in the previous classes I have told you the module instance name is an optional. Actually, instance name is an optional. But if you're in the same program, if you want to initialize a different modules, that means what, in the same program, if you have different modules, then you can give the instance name like module 1, module 2, module 3, and so on. But whereas in general, module instance name is an optional. Okay, there's nothing happens if you doesn't give any instance name. Then one additional thing is done here. What is the additional thing? A temporary wire X is declared. So here the wire X is declared. Why the wire X? We know that what is a wire? Wire is nothing but it meant for the physical connection, right? So here, as we are connecting all the gates, as we are connecting the gates, gate 1, that is XOR gate, we are connecting the XOR gate and NOT gate, right? So for the connection purpose, for the physical connection purpose, we are representing a data type called wire. Okay, so this is a wire X is declared. Then this is due to the presence of, see here, intermediate signal which is emerging from the output of NOT gate. So obviously there is a connection between the XOR gate and as well as the NOT gate. See, there is a connection between the XOR gate and as well as the NOT gate. So for this purpose, what are we doing is we are making use of a physical connection called the wire. Then the U1, U2, U3 are the names of the instances X1, XOR and a NOT gate. So just to represent or is just to initialize for each one, we are representing U1, U2 and U3. Then, so here, so this is a simple module half adder subtractor. So this is a half adder subtractor with respect to all the clubbing of all the gates that we considered. Module half adder A, B, difference and borrow. Okay, my inputs are A and B. Output difference is borrow, right? So for wire is needed. Why? Because for the connection purpose. So wire, this is X, XOR gate, U and A, and AND gate also, and then NOT gate. And finally, we are terminating our code with the end module keyword. Then, so this is a final code that I can say. Why? Because here we have clubbed all the gates, right? XOR gate, we have clubbed the XOR gate, and we have clubbed the NOT gate and also the AND gate, right? So this is a final code where we are clubbing all. This is the first part, this is the second part, and also this is the third part. So module XOR gate with by initializing input, output, and assign keyword, and then obviously we are just moving on to or considering the second stage instantiation of the AND gate, input, output, and the assign. And coming on to the third gate, input, that's the NOT gate, whereas input, output, and as well as the assign. And finally, with the end module. And the third part is about the connection. Okay, so this is the actual part of this half subtractor. So here overall we are representing in the port list what is the input, output, and as well as the input and output, and then we are initializing the input as AB, output as borrow and sum, right? So if this is a half subtractor, we have input as AB, right? AB, and the output as borrow, like difference and borrow, right? Difference and borrow. Then by using the gates, we are going to observe our difference and output, right? So representation also initialization of the XOR gate, AND gate, and NOT gate, finally end module, right? So this is a small different, or else this is a small program or else a code that we have generated from by using the switch level modeling techniques based on the half subtractor. Okay, but one thing you have to remember that the same replica is with the half adders or else a full adder. If you are considering the half subtractor, the same scenario you will find it in the full adder as well. Only the thing is, at the full adder you have the sum and as well as the carry. Okay, but the same scenario that you will see if you are considering your code as under the full adders, in the adders. Okay, and if you are going for the full subtractors, then remember that in the full subtractors you have ABC as the input. For full subtractors, ABC as the inputs, and whatever when you are subtracting the subtrahend, A is a minuend, right? A is a minuend and B is a subtrahend. When you are subtracting these two things, A and B, okay, you are going to observe, you are going to get the borrow, right? You're going to get the borrow and as well as a difference, and this borrow acts as an input, or else it can consider as one of the bit as an input with respect to the one more bit, that is 0, 1, 1. Okay, so if you subtract 0 and 1, what happens is you're going to get the borrow, and this borrow can be considered as input for this as 1 and 1, right? So if it is input as 1 and 1, what happens is the borrow is 0 and as well as the difference that you observe is 0. So this is all about the half subtractor. Hope you understand. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.